to another edition of Sudoku and Variants, where I teach you how to solve Sudoku and Variants the easy way. Today we're solving an easy level Musketry Sudoku variant. What is this? We have four 9x9 Sudokus merging in the middle, giving us this wonderful 9x9 Sudoku in the middle. But even more wonderfully, we have a technique that we can borrow from the Twodoku solving techniques to make solving this one easy. I highly recommend going over and watching how to solve a Twodoku Sudoku variant before attempting this one. I do have a wonderful tutorial that teaches the technique. I will reteach it here too. It's just that Twodoku is simpler and a wonderful introductory to the technique. The rules are that 1 through 9 must be placed in each 9x9 region without repeating in each row or column or 3x3 grid. You will not have repeated any number more than twice in any row or column. Some rows or columns will only have the number once. Take the 7 here in column 9. I count 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, I count 1, 2, 3, 4, 5, 6, 7. Notice that I do not count more than 9 either from the top or from the bottom. This means that the 7 is in both the top 9x9 grid and the bottom 9x9 grid. The 7 also happens to be in the left 9x9 grid and the right 9x9 grid. Thus, it is in all 5 grids at once. This also means that the 7 is not going to have another 7 in the same row or column as it. Notice also that the middle 3x3 grid is the only 3x3 grid that is in all 5 9x9 grids. Musketry has 5 9x9 Sudokus and one really cool feature. Every number in the outer 3 squares row will be repeated in some order in the fourth 3x3 grids row. Every number in the outer 3 squares column will be repeated in some order in the fourth 3x3 grids column. And yes, this is attempt number umpteenth recording this video. I forgot to reverse history, whatever it's called. But this time, you aren't seeing the answers. Okay, this means that the 284 in column 6, rows 13 through 15, will have these exact numbers in the fourth 3x3 grid. We count 1, 2, 3, 4. And we see 482 along the same column as the 284. If we look at column 9, 592, we know that we are missing the 9 and 2 in some order in these boxes. Looking at row 6, we see a 2. This tells us where the 9 goes and where the 2 goes. We cannot repeat a 2 in the same 9x9 grids row because this 2 is in both this 9x9 grids row on the left and in the middle 9x9 grids row. And because the 592 combo we need is in the same 9x9 grid as this 2, We know to put the 2 in row 5 and the 9 in row 6. Simply put, we cannot repeat a 2 in the same 9 squares row or repeat the same number within any 9 squares in the same row or the same column. We should see 5 to 9 in order, column 6, rows 4 through 6. Let's look at row 4, column 1. The 9-2 empty square. Musketry has another trick up its sleeve for solving them. If we were to look at column 12, rows 13 through 15, we see empty square 5, 7. Do cross-hatching, where we look at where column 12 crosses with row 4, we know that the number that completes the 9-2 empty square also completes the empty square 5-7 combo. This is because we're looking at the fourth 3x3 grid for the empty square 5-7 combo, and where it matches the empty square for the 9-2 empty square combo's fourth grid. What we don't know is if that number is a 7 or some other number. Thus, we're going to look further. If we were to look at the 3x3 grid in column 1, we see that only the 1 and 7 is missing. Going back to the 3x3 grid at columns 10 through 12, rows 4 through 6, we see a 1 but no 7. This tells us that 7 must go in this box at column 12. We cannot put a 1 here because this grid already has a 1. We can also put the 7 here in column 3. Looking at column 11, rows 4 through 6, and 11 and 13 through 15, we see a 3 to 8 and a 2 empty square 8. We can put the 3 here, as we must keep these numbers the same in some order. Let's fill in the last number in column 3, row 5. The 1. We see 5, 3, 1. 1, because the numbers must be the same in some order. We can fill in the 5 here in column 12. This gives us 5, 3, 1 and 1, 3, 5. Outer runs to the fourth 3x3 grid. Rule gives us the 5 in column 12 and the 1 in column 3. Looking at row 6, we see 6, 8, 4. This is going to help us fill in empty squares 5, 7 combo at the end of column 12. Looking at column 12, row 6 downwards, we see an 8 and a 4. We also already have an 8 in this 3x3 grid, which leaves us a 6 to go here, and, whoops, and way down here. And the 4 goes in the last spot in row 6. To explain this, we cannot duplicate a 4 in the same 9x9 grids row. If I were to have put a 4 where the 6 is, I would have 2 4s within the same 9 squares. Look at the column 10 where we just put the 4. We have a 914 combo up here, and at the bottom of this column we have square 1 9. Square 1 square. We know that we must put a 9 and a 4 down here in some order. We do cross-hatching. Look at the 4 in row 15. We can't put another 4 here, so I put the 9 here instead. And put the 4 here in row 13. What I would do is go around the outer edges, filling in what I can using the rule that doesn't have a name. Outer runs to 4th 3x3 grid. Mouthful, but it does tell us what this rule does to a point. Do think that Cracking the Cryptic might also call it this, but not 100% sure. Looking at row 7, column 1. Begins with 7. If we were to go down that row and look at the 4th 3x3 grid, then we have a 1-8 combo. This means that the full combo would be 7-1-8 in some order. Because the 1-8 is only missing one number, we can put the 7 here. Looking at the beginning of the row, I will look at the columns for a 1 and an 8. Column 2 has the 8, and column 3 has the 1. This means I must put the numbers in order 1, 8. Next row is simply a 4 empty square, 2 at the end. We also have an empty square for 2. We can look at what other numbers are missing in column 10 and note we need a 3, 5, 6, 8. This grid we want to fill in already has the 3 and 8, so we know that either the 5 or the 6 goes here. Looking at row 9, we see a 5, so we know that the 6 must go in the same row as the 5, and the 5 goes in an empty square we wanted to fill in. To complete the 4-2 combo, I put the 5 in both empty squares because they must be the same number given the outer runs to the 4th 3x3 grid rule. Also cannot have a 5 within 9 squares of an existing 5. This is why the 6 goes here. Row 9 has a 9 on the left and a 3 in the fourth 3x3 grid. Look at column 1 and 2 and try to find a 3. I do find 1 in column 2, so I put the 3 in column 1. I also put the 6 in column 2. I also put the 9 in column 11, as it's the only number left. And also because of the outer runs to the fourth 3x3 grid rule. Going back to column 1, we are missing a 1 and a 2. Drumming time, folks. A 1 and a 2 and a 1 and a 2. Okay, back to Sudoku. I see a 2 in the fourth grid in row 11. So I know the 2 must go here in row 11 and the 1 in row 12. Because we have 2, 6, 4 in row 11, fourth grid, I know this empty square. Square gets a 4 and I fill it in. Outer runs the fourth grid rule. Going back to row 10, we have 8 and a 5, and if we look at the fourth grid, we're missing the 8 and a 5. Column 10 has a 5, so I put the 8 here and the 5 here. I can also put the 9 over in column 2, row 10. Row 11 is done for the outers and the fourth grid, so we move to row 12. We look at column 3 and simply put in the last missing number, which is the 3. I know I can fill in the fourth grid with 1, 3, 7 in some order because column 3 is only missing the 3. Look at the columns 10 through 12, 12 for 1s, and then fill in 1 in column 12 as that's the only spot for it. Because each column within this 9x9 grid is only missing one number, it should be easy to figure out which number goes where. It is just simply counting or looking to see if the number is already in that column. You can do it either way. You can't go wrong. Thus, I fill in the 3 in column 10 and the 7 in column 11. Looking at column 4, rows 13 through 15, we have a 1 empty square 6. And then the fourth grid up has 1, 6, 7. We can fill in the 7 down here. This leaves us with one number left, so we fill it in. Yeah, this is missing something. Column 5 is only missing one number. This leaves us with one number left, so we fill it in the 3. Yeah, this is sloppy writing. It is missing the 3, so I fill it in. Looking up the fourth grid, we need to put in the 9 and 5. The 5 is staying nicely in the first spot in row 5, so we know we must put the 9 here and the 5 here. Column 7, outer has an 8 and a 3, and the fourth grid has the 4. We can simply put the 4 in the bottom and the 8 on top. Column 8 has a 6 and 1 and nothing in the fourth grid. Looking at the rows, I see that I have 9 squares in a row that's only missing one number, the 6. I put it in. In row 4. Row 5 already has a 1 in it. So row 6 gets that 1. This 3 by 3 grid is only missing one number, the 7, so I put it in at row 5, column 8. Column 4 has a 5, 4, 3 combo, and the bottom fourth grid is missing the 5 and 4. Using cross-hatching, I see the 4 in row 11, so I put the 5 there instead, and the 4 in row 12. Moving to the right, I have an 8 on top and a 2 in the bottom. In column 5, folks. Looking at row 3, I see a 2. So put the 2 in row 2, column 2. Looking at the fourth grid using cross-hatching, I see an 8 in row 10. So put the 8 in row 11. Looking at row 3, no. Looking at row 10, I am missing a 1 and a 4. I see a 4 in column 9. Because it has a 4 there, and because I'm on the fourth grid for the 4 in column 9, I know where the 4 must go. I must put it between the 2 and the 8 in row 10, column 9. And most importantly, I see a 1 in row 11, not column. In row 11, within 9 squares of the empty square. And it should be row 10 actually. Yeah. And most importantly, I see a 1 in row 10 with the 9 squares of the empty square. I know where the 4 must go. I must put it between the 2 and the 8 in row 10, column 9. If that 1 was not there, we could not tell if this square got the 4 or the 1 because both are in the upper outer 3 by 3 grid in the same column. Here I put the 1 in the other spot as there's no other place left. I also put in the 1 in row 3, column 5. And then move to column 8. I see 2, 5 on top and 2, 3 in the 4th grid. Because the outer runs to 4th 3 by 3 grid rule, I can easily put the 3 on top and the 5 on the bottom. Five is going in row 12. I'm skipping column 6 because nothing tells me anything. There's no 6 anywhere in the upper outer regions in rows 1 through 3. And the 7, 9 that's missing in the bottom 4th grid has a 7 and 9 in row 1. Not useful, except we do know where the 6 must go, and I'm going to put it in anyway, in row 1. See how pretending to skip column 6 told us where a 6 should go? I know that column 6's 4th grid is missing 7 and 9 because row 1 already has a 7. Row 1. Try row 11. Yeah, this doesn't work. And because row 1 already has 7, 9, I cannot put another 7 or 9 here. Plus, outer runs the 4th grid rule dictates I must put a 6 here because 7, 9 is already in row 1. Looking at row 11, we see a 9, and row 12 has the 7. And I cannot put another 7 or, yeah. Notice that this 7 in column 15 is not within 9 squares of where we want to see if a 7 goes. This means that with the 9 in column 7, we must put the 7 in row 11 in column 6 and the 9 in row 12. Looking at column 9, we have a 4-1 combo and a 4 only in the fourth grid. Using crosshatching, you can see a 1 in row 12, thus the 1 has to go in row 11. I see an 8 in row 11, which does not matter. Okay, because the row 12 is only missing the 8, we know that we need an 8. Plus this 3x3 grid is only missing the 1 and 8. I see an 8 in row 11, so I put the 1 in row 11 and the 8 in row 12. I also put the 8 on top in row 3. Column 10 is only missing a 3. Because that is the number in the fourth grid, 823, 382. Column 11 needs a 5 and a 6. We see where the 5 is in row 3, so I put the 5 in row 2 and the 6 in row 3. Column 12 needs a 9 for a 1. I see a 9 and a 4 in row 1. So I put a 1 here. I see a 4 in row 2. So I put the 9 in row 2 and the 4 in row 3. Let's fill in the missing numbers in row 2 and 3. Do I really mean rows? Apparently I do. Okay, looking at column 6, we're missing the 7 and 9. Because we see a 9 in row 2, we can put the 7 in row 2 and the 9 in row 3. We are now only missing one number in each row and can now simply fill those in. Counting 1, 2, 3, 4, 5, 6 is missing. We fill in the 6 in row 2. And counting in the middle grid, we see we are missing the 7 and put it in. outer row 4 on the far right, we have a 3-1 combo, and if we count to the fourth grid to the left we see a 4. We can fill in the 4 in column 13. Row 5. Row 5, fourth grid, has the 6, 9, 8. And the outer on the right has an 8. Cross-hatching reveals the 6 in column 13 and a 9 in column 14. Thus, I must put the 9 in column 13 and the 6 in column 14. Moving on down to row 6, we have 7 in the outer and the 752 combo in the fourth grid. I see the 5 in column 15, so I put the 5 in column 14 instead. And then fill in the 2 in column 15 and move on. Six, 9, 5 is the outermost 7, but the fourth grid on the left is devoid of anything useful. However, cross-hatching shows me where the 9 and 5 cannot go, which is column 5. Thus, I can put the 6 here. I see the 5 in column 4. So put the 9 here, because this is not the fourth grid to the column 4's number 5. So let's put 9 here and not duplicate the 5. 5 really goes to the last spot here in column 6. Row 7. Moving down one row, we see 8, 7 combo in the left fourth grid and nothing in the outer region. Look for an 8 or a 7 and find both in column 15. I then look at column 14 and find nothing. I look at column 13 and find a 7. I put the 7 in column 14 and the 8 in column 13. Looking at column 5, I'm missing only one number in the 9 by 9 grid. 1, 2, 3, 4. 4 is missing. I put in the 4. Let's look at row 11, left fourth grid, where I see the 5, 8, 7 combo. The outer only has a 7. Look at column 13 and see the 8. So put the 5 in that column, column 13, and the 8 in column 14. Moving down to row 12, I have 4 to 9 in the fourth grid and only a 4 in the outer. I see a 9 in the 13th column, so I put the 2 in this column and the 9 in column 15. The row 10, fourth grid, has the 3, 1, 6 combo, and the outer only has a 1. I see a 3, 6 column 14, which doesn't matter. I see a 6 in column 13, so I put the 6 in column 15. And then I put the 3 in column 13. Now to where we see about row 9 and what numbers are missing in columns 13 and 15. And column 14 for that matter. We know we need a 2, so we look at column 13 and find a 2. We also see a 2 in column 15. So thus we can safely put the 2 in column 14. Looking at row 9, right side of 9 by 9 grid, we know we're missing numbers 1 and 4. We can now look at column 13 for a 1 or a 4. I see a 4, so put the 1 in column 13 and the 4 in column 15. We are only missing one number in this middle right 3 by 3 grid, so I've put in the 3. Column 7 is only missing one number. I count 1 not found, so I put it in. Row 8 on the right has the 873 combo, and the fourth grid is only missing the 3, so I put it in. Row 9 outer has the 124 combo, and the fourth grid is missing the 1, so I put it in. Row 9, this leaves us one number for row 8. The 6 is missing, so I fill that in. Moving on down to row 13, I find I'm only missing the 7, so I fill that in. This leaves us with column 8 needing only a 4. And column 9 only needing a 3. We are done. Congratulations on solving your first easy musketry. Please like, subscribe, and share so I can grow this channel and keep bringing you more content. I hugely appreciate it. Thank you and bye.